All right, so exponential logarithmic equations with compound interest. All right, keep your answers as reduced fractions when possible. If a decimal cannot be turned into a fraction, round to 3 decimal places. If it's money, then we round to 2 decimal places. So the first type of exponential equation that we want to look at is when both sides can be turned into the same base. So when dealing with these, if the bases are equal to each other, you just set their exponents equal to each other. Okay, that's just pretty much how this works. So the first one, we have 4 to the 3x and 32 to the x plus 1. So what base can they both be written as? A base of 2. So I'm going to change the 4 to the 3x into 2 squared to the 3x. Because we know 2 squared is equivalent to 4. And what's 32 as a base of 2? 2 to the 5th. So 2 to the 5th to the x plus 1. Well, when I raise a power to a power, I multiply them, right? So that's 2 to the 6x equals 2 to the 5x plus 5. So now that they both have the same base, we just pull their exponents out and set them equal to each other. So now I just solve this simple equation. Subtract 5x, and we can see that x equals 5. And that's how you solve that. Any questions about that? Okay. So the next one, we'll do the same thing when we have like bases. 3 to the 2x plus 5 and equals 1 over 9 to the x minus 1. So we already have the 3 as a base that we can't simplify any further. But 1/9, what can that be written as? 3 to the negative 2. To the x minus 1. And so now we can multiply those together, that negative 2 and that x minus 1. So now that they have that common base, we can set those exponents equal to each other. We'll add 2x to both sides and subtract 5. And we have 4x equals negative 3. Divide by 4. And x equals negative 3/4. That's my answer. Any questions about that? Yeah, this stuff is pretty easy until it gets out of being a like base. Then they can get weird. All right, so the next one. You have a couple extra things going on with this problem. All right, so we have 25 times 1 over 125 x to the 4th equals the square root of 3125. So what base can we write all those as? Base of 5. So the 25 we're going to change to 5 squared. The 125 we're going to change to what? Well, 1 over 125. 5 to the negative 3 raised to the x plus 4 equals, well, what's the square root of 3125? I think you get a decimal answer. All right, so, but what is 3125 in terms of a base of 5? 5 to the 5th. So that means we can take 5 to the 5th and raise it to what? To the 1/2. And that's how we'll work with that. So now we have a bunch of exponents. Now we need to start combining everything that we can. So we'll distribute this negative 3 to the x plus 4. And change that to 5 to the 5/2. Now I have this 2 and this negative 3x minus 12. What can I do with those? When they have like bases and they're multiplied, what do I do with their exponents? You add them. You add them. So we'll combine those like terms. So it's 5 to the negative 3x minus 10 equals 5 to the 5 halves. We just added that 2. Yes.
So why would you multiply the
5 times 1 half.
the bases for the how we added them?
Mm-hmm.
So why wouldn't it be 25 to the 2x?
Because in essence, let's like x squared times x to the third is what? X to the fifth. The x doesn't change, you just add the exponent. Okay, so now we take their exponents and set them equal because we have a common base now. So negative 3x minus 10 equals 5 over 2. What's the easiest way to solve this? Multiply everything by 2. Get rid of the fraction. So it gives me negative 6x minus 20 equals 5. So I'm going to add 20 to both sides. Negative 6x equals 25. Divide by negative 6. And x equals negative 25 over 6. And that is my solution. That one's a bit lengthier than the other ones. All right, so the next set, we want to move to when there is not a common base. So when there's not a common base, you have to use a logarithm to solve an exponential equation. So we have 3 to the 2x minus 1 equals 7. Well, in order to solve for x, I need to get it out of the exponent. We were able to do that easily because in the previous problems we had a common base, so once we found the same base on both sides, we just pulled the exponents out. But this is not the case because you can't get a common base between 3 and 7. But we do have a rule that allows us to pull exponents to the front of something, right? And what rule is that? The power rule. The power rule. It allows us to pull an exponent to the front as long as we have a logarithm there, right? So what I want to do here is I'm just simply going to take the log of both sides. You can use the regular logarithm or you can use ln, the natural logarithm. Doesn't matter which one you use, you're going to get the same answer either way. Okay. And I'm going to use ln because it's just less to right. So if I take the ln of both sides, now I can take this exponent and I can pull it down to the front. So now we just solve for x at this point. So I'm not going to distribute the ln of 3. I'm just going to divide by it first. So 2x minus 1 equals ln of 7 over ln of 3. So now I add 1 to both sides. 2x equals ln of 7 over ln of 3 plus 1. And notice I haven't done anything to it yet. I haven't simplified. I haven't done nothing. I'm just doing those algebra steps. And then divide by 2. So this whole thing equals x. So if I want to know the actual answer, I'm going to type it in the calculator. Alpha x. Okay. And there's your x value, 1.386. Either answer I'm okay with. If you leave the answer like this, I'm okay with that. If you find the decimal answer, I'm okay with that. I'm more concerned that you actually know how to solve it. Okay. Any questions about that? All right, let's look at the next one. What should I do first? Nope. Divide by two. The difference between this one and this one is this one's an exponential function with a coefficient in front of it. Always divide by anything that's multiplied by the exponential function first. So e to the 5x equals 8. Now what should I do? Ln. Yes. See, this one we don't have to worry about moving it to the front because ln cancels out who? Ln cancels out e. So it just gives me 5x equals ln of 8. And so I simply just divide by 5. So x equals ln of 8 over 5. Question about that one?
So is it okay if we just leave it like that, or do you want it?
You can leave it just like that.
So do we solve for or like we plug it in?
You can leave it just like this.
So why do we plug it into the other one but not that one?
I just wanted to show you how to do it in the calculator. I honestly don't care. As long as you get to this point or this point, I'm okay.
So you're not gonna ask us.
I think this test is multiple choice, so it's going to be.
That's what
Hmm. It's multiple choice, though, but I won't be on the computer. All right, the next one. I think the next two tests are multiple choice. But after that, it's over. All right. 12 over 1 plus e to the negative x equals 2. Now, there is a trick that I normally teach when everybody gets to this class. And where's the variable located? In the denominator. Whenever you're trying to solve for a variable in the denominator, switch it with the other side of the equal sign. Listen, and trust me, it's mathematically correct. And I'll show you why.
why haven't all my teachers?
Where's my variable? How would you really solve for something in the denominator? Multiply by x. So you get 1 equals 5x. Then what would you do? What switched? They just switched places. Okay. So whenever you're solving for a variable in the denominator, you just switch it with the other side of the equal sign. I did.
So that works.
Yeah, I really did. Yeah. I teach it to all my classes. Always. Always. Yeah, it saves time. So now we just subtract from 1. So 7 equals e to the negative x. 5, not 7. I don't know what I'm doing. Thank you. So take the natural log of both sides. Negative x equals ln of 5. So x equals negative ln of 5. Now, the only thing about this answer is you could see this another way. You could see this as ln of 1/5, and it'd be positive. The negative 1 that's sitting right here, it could be moved back to 5 to the negative 1, which is 1/5. Yeah. Just something to watch for in case if you ever see this on a test or ACT or something like that, and the answer looks like this, but you found this, you can convert them back and forth. Huh? Oh.
Oh yeah, because it was like over. It was like instead of 1/3, it was like over 3, and I was like, what?
Oh yeah, same thing. Same thing. All right, this one. What does this look like? A quadratic. Looks like a quadratic. Factor it as a quadratic. What are the factors of -6 to add up to -1? -3 and +2, right? Okay. Typically, you would put x right here. And do you guys know why you always put x there? What if it was x to the fourth minus 2x squared plus 3? What would you use instead of x? You would use x squared. You're always using this one, the middle.
Chill, bro. You're teaching me way too much on this.
You're always using the middle one. Because a quadratic, the middle term is just x. So that's the one you use when you factor. So this middle one is e to the x. So this is e to the x minus 3, e to the x plus 2. So now that it equals 0. So whenever we saw quadratics that are equal to 0, when we have their factors, what do we do with their factors? Set each one equal to 0. This would result in e to the x equals 3. And this will result in e to the x equals -2. Right? All right. Which one of these will not be of use? Because it's negative. There is no way to get e to the x to equal a negative number. Because if you plug in negative exponents, what happens to them? It just flips. It never becomes negative. Okay. So take the ln. X equals the ln of 3.
It's easy right now.
Fun stuff. Fun stuff. All right, compound interest. Um,
Yes.
that's the formula for it. All right, n is the number of times it's compounded annually. So n would be represented by these words. Annually means 1. Monthly means 12. Semi-annually means 2. Quarterly means weekly 52.
How do you just know your weeks?
We don't count those. And daily would be 365. And then you have the compounded continuously formula. Hurt.
Oh my gosh. I bet he was crazy.
All right. So A is my final amount. P is my principal or initial amount. R is my interest rate. And T is time in years. So these questions, you actually have to apply those same rules, those same ways we solve equations to these questions. It's pretty much the same. It's just now you have a word problem to work with rather than just a plug and chug problem. So Mike decides to invest $400 into an account that has a 6% interest rate. So I want you to find the amount after 4 years compounded monthly. How would you do that? Hmm? I was like, what are you trying to find? You're trying to find A, right? So A equals 400. 1 plus, what's the rate? 0.06 converted to a decimal. Compounded monthly, so what is N? And 12 times 4, because 4 is T. So type that in your calculator. Guys, please use that fraction bar, alpha x. It eliminates the need for a whole bunch of parentheses. And it ensures that your calculator does the correct order of operations. So 50820. It's literally written at the top of your notes. All right, find the amount after 4 years compounded continuously. So rather than using this first formula, we're going to use our PERT formula. Yep. Second ln. You get 508.50. So you get about 30 cents more if you compound continuously. Does anybody know why?
Wow.
Yes. And there's more. Well, with compounded monthly, it's literally compounded once a month. That's it. But when it's compounded continuously, it's just compounded over and over and over and over and over again. But the interest rate is so small, it's not adding a whole lot every single time. So it's just compounded like an infinite amount of compounding within that year span. Not infinite per se, but it's a countable infinite type idea. Anywho, because E itself, the number E is a limit. And we'll talk about those later. All right, how long will it take you for the investment to be $850 if compounded continuously? So what am I looking for now? Time. I'm looking for T. Because it says how long. All right, so my A value is going to be the 850. My initial amount is still 400. And it's 400 e to the 0.06 t. So I'm going to divide by 400 first. And that gives me 2.125. So how do I get rid of the e? Take ln of both sides. So ln of 2.125 equals 0.06t. And now to solve for t, we will divide by 0.06. T equals 12.563. So a little over 12 and a half years.
Would we put the decimal for it, or since it's time we just put
You put 12.5. 12.563. 3 decimal places. Yes. Yeah. No. Yeah, you don't want to try to do logarithms without a calculator. I don't even know how to do those without a calculator. I don't think that's something they teach.
Mr. Cobb, I have a question.
hmm
So why did we bring the ln down to 12.56?
Because we typed it in the calculator.
I didn't know.
All right, how long will it take for the investment to be 5,000 if compounded quarterly? So now we go back to the longer equation. 5,000 equals 400. 1 plus 0.06 over quarterly. What goes for n? 4 to the 4t. So divide by 400 first. Huh? Go ahead and find out what this equals, the 1 plus 0.06 divided by 4. So now we need to do what? We need the exponent down, ln. So ln of 12.5 equals 4t, ln of 1.015. So I'm going to divide. What would you do here? Divide by what? Some people say 4, some people say ln. Do both at the same time. And they both just cancel out. It's perfectly okay. So t equals about 42 years and 3 months. No, 42 years and 6 months. Nope. 5. 5. All right, any questions about that one? I know it's a lot of steps, but it's the same process over and over again. Simplify it, take the log of both sides, solve for the variable and the exponent. All right, the last one for this little section says 2250 is invested in compounded semi-annually for 7 years. Find the rate if the amount is doubled in the given time. So what am I looking for? I'm looking for the rate R. So what is A? Why is it 4,500? Because it's doubled. What is N? 2 because it's semi-annually. And NT would be 2 times 7, which is 14. First step, divide by 2250. And we know that's 2 because it just multiplied by 2. I mean, you did just multiply 2250 times 2 to get 4,500. So I have something to the 14th power. How do I get rid of that? Take the 14th root. Listen, your calculator doesn't. Go to math and hit number 5. So it's 1.051. So what are we going to do? Subtract 1. Multiply by 2. So about 10.2%. And that's your answer for that one. Okay. Questions about that? All right, so the next side is logarithmic equations. They're the same idea, same concept. When both sides have a logarithm in every term. So like for this right here, you have log base 5 here, log base 5 here, one logarithm on each side. Just set their arguments equal to each other. And solve for x. I'm not actually going to go through the whole problem because at this point you should be able to solve for x. So that's all you have to do for this one. Okay. Questions about that? The next one, what do we have between these logarithms? Addition, so I can combine them using, so that would give me log x times x minus 3 equals log of 28. So now that I have one log on both sides, I just set their arguments equal to each other. That turns into a quadratic. Now, your notes up here tell you some solutions may or may not work. Could also have no solution. You need to check them. What can a logarithm not have in its argument? A negative or 0. Okay. So the solution cannot make the solution itself can be negative, but it can't make the argument negative. For example, if I get a negative x right here and I plug it in and it makes this whole thing negative, then it's not a solution. Okay. So what would you do with these two? Right. And you solve that equation. Same thing for this one. This would be a quadratic as well. Okay. Now, let's move to the bottom part because these are the ones that are more challenging. All right, so when there is a constant on one side and a logarithm on the other side, rewrite it in exponential form. Okay, that's the first thing we did on the first day we talked about exponents and logarithms. So 3 to the equals 2x plus 15 and solve for x. So 9 equals 2x plus 15. Negative 6 equals 2x. So x equals negative 3. And if I plug negative 3 in, it gives me negative 6 plus 15 is 9. So that's good. It's positive, so I'm okay. This one, combine the logarithms first. And then we change it to exponential form. So 6 to the second equals 8x squared plus 4. Distribute the 2. And then just solve this. A lot of these are going to result in quadratics and stuff like that. But it shouldn't be too bad. Problems like this, you need to get the logarithm by itself first. So subtract 4. Then divide by negative 6. Equals 4. Now, how do I get rid of this ln? Use the e. If ln cancels out e, then e will cancel out ln. So those will go away. So 3x plus 1, 3x minus 1 equals e to the 4th power. Because when you use e to get rid of it, you're raising it using e, not multiplying by e. So add 1. So 3x equals e to the 4th plus 1. Divide by 3. X equals e to the 4th plus 1 over 3. And you can leave it like that. And for the last one here, this will be ln of x plus 4 over x minus 5 equals 2. Same thing, use e again to get rid of the ln. And then just solve for x. Multiply both sides by x minus 5 and all that kind of good stuff. All right, any questions?